All right, guys. Hey, welcome back to another lesson. A little bit different type of lesson today. It's going to be parallel line proofs. And essentially, what we're doing is we're going to give people looking at these problems, we're going to give them an outline as to how to get from answer A to answer B, okay? Or how to get from A to B. So we do have a method for this, and for a high school setting, we're going to do a T-chart proof. Okay, we could do paragraph proofs, proofs by contradiction. There's a lot of different ways of proving things to be true, but for this class, we're only going to worry about T-chart proofs. Okay, I will possibly upload some other videos showing you some different proofs dealing with this topic. Not something you'd be tested on, but you can at least see some other possible areas for this concept. Okay, sorry, I'm a little tongue-tied today. So a proof, and if you want to bake, there's a recipe for you. But a proof is like a recipe. Okay, there's a reason why we do each step, and there's an order to it, right? For instance, I'm not going to add eggs after I'm done baking the cake, right? I'm not going to just crack a couple eggs open on the freshly baked cake that I take out of the oven. That doesn't make sense, right? So there's an order to these proofs that we're going to think about. And the other way that we're going to think about proofs is not only the order of it, but the reasoning for it, okay? Why do we add ingredients together in a certain order, okay? So thinking of proofs in this fashion might help you understand what we're doing here, okay? So how do we set up a two-column proof? This is one way of doing it. And like I said, we're not going to do paragraph, flowchart. We're not going to do those specifically. We'll look at some, okay? But right now, I want to focus on T-chart proofs, okay? On one side, we're going to list all of our steps. The other side, we're going to list all of our reasons. So you're going to list all the given information first, okay? Once we have that listed, then we're going to start adding some other observations that we see in the problem, and then we're going to see if we can't get to the conclusion. Now, for the first couple problems, here's the goal. We want to find an angle that connects the proof part with the given part. That's going to make more sense when we look at an example. And then for step 4, list your steps with a reason. So every time I list a step, I should have a reason as to why I'm listing it. Okay? So a little vague right now, so let's just jump into an example. Okay? So here's our first problem. Okay? And for this, we're going to set up a nice, long, big T. This is a statement column. This is a reason column. Okay? So let's read what it asks. Okay, we're given, and remember those double bars mean parallel, that J is parallel to K and line L is parallel to N. So everything's parallel here, so I don't have to worry about any ambiguous cases, anything like that. And they want us to prove that 1 is congruent to 3. Currently, there's no angle relationship that says 1 is congruent to 3, right? Okay, they're not corresponding, they're all alternate interior, alternate exterior. So we have to make that connection. Okay? So let's plan this out first. So what I can see here, and remember the goal is to find an angle that 1 and 3 both have in common. All right, keep that in mind. In fact, let me write this right down here. So the goal is to find an angle that is congruent, I'm going to use the symbol, to 1 and 3. All right? Now, there's a lot in this picture that you can choose from. Here's one that I thought of. 1 and 4 are congruent because they're corresponding. 3 and 4 are congruent because they are corresponding. So that means angle 4 is what's common to both of them. Great. I'm going to use that method to prove that 1 and 3 are the same. Okay? Now look at angle 2 and 5. See how they're just lingering out there? Could you incorporate them? Could you use them in a different proof? Absolutely. Okay? But I'm just using the angles that I need. So the first step in this proof, I'm I'm going to list the given information. Hey, I'm going to tell the reader J is parallel to K, L is parallel to N. And the reason why I'm listing it is because it's given information. Okay? So that's always going to be your first step, list your givens. Okay, now my second step. And in this case, it doesn't really matter what you start with first. I'm going to say that angle 1 is congruent to angle 4 because they are corresponding angles. I'm going to abbreviate angles there, okay? Now, for my next step, I'm going to list the other fact that I just stated, that angle 3 is congruent to angle 4 because they are also corresponding angles. Now, here's the cool part. It's a different color. You see how we just stated that we wanted an angle that 1 and 3 are both congruent to. They're both congruent to 4, right? So can't we reason that 1 and 3 have to be the same measurement? If angle 4 was 60, then isn't 1 60 and 3 is 60? So they must be the same, right? Perfect. So let's go ahead and state that now. So we just told the reader, the person looking at this problem, we made the connection for them that 1 and 3 have angle 4 in common. So therefore, 1 has to be the same measurement as 3. Now here's where the reasoning comes into play that you might not remember, but this is called the transitive property. And I spelled transitive wrong. Hold on. Transitive property, okay? Transitive property means that if two variables, two values, two angles, whatever you want to call them, depending on the situation you're in, if two angles have the same measurement or the same angle in common, then they must be equal to each other. So for instance, like I said, if, just for example, if angle 4 is 60, then angle 1 is 60, right? 60 here, 60 here. So these must be the same measurement, okay? So when you find that angle that they're both congruent to, they must be congruent, therefore it's a transitive property. Now you might ask, well, why don't I just plug in a number to begin with and show that it works for 60 degrees? You could, but why am I not doing that? Well, you just proved that 1 and 3 work if the angle's 60. What if the angle's 59 degrees? It still works, right? But you have to explain the process again. Hey, if this is 59, this guy's 59, which makes this 59 degrees, okay? So to make sure this works for all measurements, not just for one specific one, we're making this purely an all-case situation. Does that make sense? That's why we're doing this, okay? Not just for one single case. All right, there's our first problem. Let's try another. And I'm going to erase this here. This is gone. Goodbye, so long. See you later. There we go. Okay, so we know that line C is parallel to line D. And hey, they give us some information. They say, hey, 4 is the same measurement as 3. Now, visually, and knowing our information of angles, we couldn't really make that assumption, right? We couldn't really say 3 and 4 are the same unless we measure it. So since they gave us that information, we're going to use it, okay? And we want to prove that 4 and 2 are congruent, that they're the same measurement. Okay, so our goal is to find an angle that's congruent to angle 4 and angle 2. We're trying to find that connection, all right? Now, here's the good news. You see the given information? They kind of give you a hint. They say 4 and 3 have a relationship. They're the same. So let's look at 2. Does 2 and 3 have a relationship involved? Yeah, they do. They are congruent because they are corresponding. Okay, so it looks like angle 3 is going to be the connector for 4 and 2. So first step, we're going to write down the given information. C is parallel to D. If you want, you could list the given in different steps. So for instance, step 1, I'll say they're parallel. That's given information. Step 2, angle 4 is congruent to angle 3 because that was also given to us. All right, so you could separate that if you'd like. All right. Now, 2 is congruent to 3. And we said the reason why they're congruent to each other is because they are corresponding angles. Okay. Now take a look at what we have. I'm going to make this in blue again. 4 and 2 have angle 3 in common. So once again, if angle 3 is 50 degrees, so is angle 4. Angle 3 is 50 degrees, so is angle 2. They're both the same measurement, right? So at any time, because proofs can be tricky, because a lot of times you don't have numbers involved with proofs. You could, and we'll see that in a bit. So just plug some numbers in to make that connection. That could help. So therefore, okay, angle 4 is congruent to angle 2, and that's because of the transitive property. I'm just going to abbreviate for that one. Okay? And we're done. So notice, the beginning of my proof has the given information listed. The end, the very last step, is always the proof part, what you're trying to prove here. Okay? Now you might ask me, well, Mr. McCullough, what about angle 1? Oh, what about angle 1? So what? No, I shouldn't say that. You could incorporate angle 1. It will make the proof a little bit longer stepwise. Okay? You might have to use transitive property twice. 2 and 1 are congruent because they're vertical. 1 and 3 are congruent because they're alternate interior. So you could say that 3 and 2 have angle 1 in common. That's transitive. And then you can make the assumption that 2 has to be congruent to 4 because they have 3 in common. So, I mean, it's probably another 3 steps, but it could be a little bit more confusing since this is your first time constructing a proof. So what I would recommend, if there's extra angles involved, just don't throw them in there just because they're there. Only use the angles that you need to. Okay? All right. Moving on. Okay. We got one more, and then we're going to change gears. Okay? So example 3. We're given that L and M are parallel, so that means we can use alternate interior, alternate exterior, all that stuff. Angle 2 is congruent to angle 4. They tell us that information ahead of time. That's very nice of them. My phone is ringing right now. Should I answer it? That's the question. Give me a moment, guys. Hello? Okay. Right now I'm in the middle of recording the video, so I'll try and get some stuff together. Oh, can I email to that? Okay. Yeah. All right. Thanks. Bye. Hey, see, this is live. It's like live television. You don't know what's going to happen. All right. I apologize for that little dead space there. All right, we want to prove that 4 is congruent to 3. Okay, so once again, the goal is to find an angle that's congruent to 4 and angle 3. Now, the given information gives me a hint. 4 is congruent to 2. So maybe angle 2 is that angle we're looking for. Well, let's take a look. 3 and 2, they're the same, right? They're alternate interior angles. So I think we have a good, solid track as to what we're going to do here. So first couple steps, or just you can list these all at once, doesn't matter. L is parallel to N because that's given to us. Angle 2 is congruent to angle 4. All right, and that's because it's given to us. All right. Now, we said that angle 3 is also congruent to angle 2 because they are alternate, I'm going to abbreviate here, interior angles, or else I won't be able to fit the whole thing. All right, taking a look, I could see that angle 2 is what they have in common. So what I could say is that angle 4 must be congruent to angle 3. Okay, and that's due to the transitive property. Okay, once again, I'll just, oh my gosh, I have another phone call. Hello? That's okay. Okay. All right. Okay. Yeah. Okay. Yeah, that's fine. Okay. Oh, okay. Yeah, that's fine. I'll be done probably in like 10 minutes. So once again, you're just gonna have to speed through that part of the video where it's like that. Okay? And that's it. Any questions on that? Thoughts, concerns, dilemmas? So the goal is to find an angle that they have in common. Okay? Sometimes you have to find that, or sometimes the given information gives you that clue. Okay? Alrighty. So now we're going to change gears. These last two examples, see how we're talking about measurements of 180 degrees? Okay? So we're going to think of something a little bit different here. All right. Now, 180 degrees. What type of angles give me that measurement? Well, linear angles do, right? And same side interior angles. So you want to keep that in mind. So they tell me that BD is parallel to FE. Okay. So here's your goal, a new goal that you're going to look out for. Because we're trying to prove that 3 and 5 add up to 180 degrees. Now, currently, there's no way for us to express that, but we have to try and figure that out. Okay? So our goal, okay, is to set up an equation that has angle 3 or angle 5 in it. Then substitute a value that will lead to the prove part. Okay? Now this might look a lot right now like, what the heck is he talking about? Well, it's going to make more sense when we actually start talking about this proof. 3 and 4. See how 3 and 4 are vertical angles? Okay? So whatever 3 is, 4 is the same measurement because they're congruent. So can I just put 3 where 4 is because they're the same? And then 3 and 5 are same side interior, so they add up to 180 degrees. So already I have a plan in mind. Now I just have to put it on paper to make that conclusion. So my first step is to still list that these two lines are parallel. So that's what's in the given information. Ah, I can't spell. There we go. Help, I can't spell right now. All right, second step. Okay, I'm going to make the statement that the measurement of angle 3 equals the measurement of angle 4. And that's because they are vertical angles. I'm abbreviating that, by the way. Okay? Now, note what I just did here. See how I changed? I wasn't using congruent symbols anymore. I'm using equal signs. And the reason why I'm doing that is because I have an equation here. So I'm not going to mix up congruent symbols with equal signs. I don't want to mix those up. So I'm going to go ahead and ignore the congruent signs and just focus on equal signs. Okay? So my next step, we want to come up with an equation that has 3 or 5 in it. So I'm going to say the measurement of 4 plus the measurement of 5 equals 180 degrees because they are same side interior angles. Okay? So I created an equation that has one of the angles I'm looking for. Now, here's the cool part. And maybe you see this already. I'm going to grab a different color here. Okay? You see how this step says 3 is the same thing as 4? So look at this equation. I have 4 right here. I can substitute angle 4 for angle 3 because they are the same. So I'm going to make that substitution. So the measurement of 3 plus the measurement of 5 equals 180. And this isn't a transitive property in this case. It's a substitution. Okay? The reason why it's substitution is because I'm taking one number out and I'm putting another number in its place. Okay? Does that make sense? Transitive, we're going to reserve that property for if two angles have an angle in common, okay, that they both share. For substitution, if I'm taking one number out and replacing it with a different one, that's when we're going to use that guy. All right, now look, is this what the proof part says? Absolutely. So I just proved that 3 and 5 add up to be 180 degrees. Okay? The second and third step, you could flip those. It doesn't matter the order for those guys. Okay? Because logically, you're still seeing the same thing. Okay? A little bit different. We have some measurements involved, but it's something that we can still do together. Okay? You might see other teachers, other videos out there that say, well, wait a minute. You're supposed to say they're congruent first and then say their measurements are equal. You can do that, okay? I am fully aware. I'm skipping that process just to make this a more narrow and simplified approach to it so you can understand this stuff, okay? I don't want to add all the other fluff to these proofs. I want to be very direct, okay? So if you look at other videos, you might see some differences in there. And I'm aware of that, all right? We got one more problem to go, guys. And it's a very similar setup. Okay. So we want to prove that angle 1 and angle 2 add up to 180 degrees. Now currently they don't. There's no relationship between 1 and 2. We have to make that connection. So we got to make an equation that adds up to 180 that has angle 1 and angle 2 in it. So what about 2 and 3? 2 and 3 are linear angles. They add up to 180. But I don't want angle 3 in there, right? But here's the deal. 1 and 3 are corresponding. They're the same measurement. So 1 I could bring down to here, and then I could say, hey, 1 and 2 truly do add up to 180 degrees. Okay? So the goal is set up an equation that has either angle 1 or angle 2 in it. So that's what we're going to do. So first step, we're still going to list the given. All right. Step 2. Doesn't matter what we do first. We can do this first just to show a variation. The measurement of angle 2, we'll say 3 first, plus the measurement of angle 2 equals 180 degrees. And that's because these guys are linear angles. Some people might say they're supplementary. Okay, some proofs might list that 2 and 3 are linear and then go to the next step. There are so many ways of stating this, it's ridiculous, okay? So once again, if you watch other videos, you might see a different approach, a different way of writing it. I'm just trying to streamline this so that we can get the basic understanding, okay? All right. Next, notice this does not look like my proof part. I want to get rid of 3. So I know that the measurement of 3 equals the measurement of 1 because they are corresponding angles. So now take a look. this. This is pretty cool. Here's 3. Anytime I see an angle 3, I can swap it out for an angle 1 because they're the same measurement. So I'm going to do that. So the measurement of 1 plus the measurement of 2 equals 180. And I got to this because I substituted, which I'll abbreviate as SUV. Okay? And there we go. So we just made a nice logical conclusion that 1 and 2 do add up to 180. And that's because 1 and 3 are corresponding. So I was able to swap those values out to prove that. Okay? And that's it. That's as far as we're going to go right now. 5 examples with 2 phone calls in the middle of it. I apologize. Just like you're in the actual classroom. I will be posting other videos of proofs later on throughout the week, so stay tuned for that, okay? I'll also try and post some videos of me going through some of the homework too, because this is a little bit different. It is, okay? So don't be afraid. Don't be afraid to ask questions. Don't feel intimidated by it. This is a different concept for you to try out, all right? But that's it, guys, okay? So take care. Have a great day, and I'll see you in the next lesson video.